So, hello everyone. This is chapter 4 of ninth class NCERT. We are doing science, and this is the last chapter for the chemistry for the ninth class. And here we will study about the structure of atom. All right. Now, in chapter 3, we have learned about the atoms, molecules, and fundamental building blocks. All right. Now, here we will look in deeper in what happens actually inside the atom. Now, if we rubbing two objects together, we can see electrically charged, right? You can just take scale, rub it on your hair, and then keep some distance, and you'll find that your hairs are attracted towards your scale. This is because of some electrically charged particles. Now, the scientists contributed in revealing the presence of charged particle in atom. That means there are some charged particle in an atom. An electron is identified by J.J. Thomson. We have to remember it. Electron was identified by J.J. Thomson. Now E. Goldstein in 1886 discovered that the presence of new radiation in gas discharge and called them canal rays. That means Goldstein has done the Callan rays experiment, and these rays was positively charged radiation, which ultimately led to the discovery of another subatomic particle. Now, the subatomic particles have a charge equal in magnitude but opposite in sign to the electron. That means he found out the proton that was equal in charge but lesser in magnitude. Sorry, same magnitude but opposite charges. And the mass was approximately 2000 times as that of electron. That means proton was heavier than electron, and it was given the name proton. Generally, electron is represented by E minus and proton as P plus, and proton is taken as one unit and it is charged as blue plus one, and the mass of an electron is considered to be negligible and its charge is minus 1. All right, let's move forward with it. This is the structure of atom, and here is J.J. Thomson, who has found out the electron, and the Goldstein was there who found out the proton. Now, the Dalton atomic theory suggested that the atom was indivisible and indestructible. The discovery of two fundamental principles, electron and proton, inside an atom led to the failure of aspect of Dalton atomic theory. Now, what was the Thomson model of atom? Now, he found it out like that. That means it is quite like an watermelon, Thomson. But he actually found out the electron. He is told that the everything inside is positive sphere, but the electrons are like the seeds in between the in that positive sphere, like watermelon. The positive charge in the atom is spread all over the red edible part of the watermelon, while the electrons are spread in positively charged sphere like the seeds of watermelon. So this was the J.J. Thomson's idea, and Thomson proposed that the atom consists of a positively charged sphere and the electron are embedded in it. All right, and negative and positive charges are equal in magnitude, so the atoms can wholly in the electrolytic neutrality. It told that the I'm sorry. He told that the both the protons and neutrons. So I mean electrons, the both positive and negative charge are balanced. They are stable. Now Rutherford did the model of an atom. All right. There was Goldstein who did the cation rays experiment, and there is Rutherford model of an atom. What he did, he took the fast-moving alpha particles made were made to fall on the thin gold foil. He arranged a gold foil and he was passing alpha particles in it, and he selected a gold foil because he wanted a thin layer as possible, and this gold foil was about 1000 atom thick. Now alpha particles are doubly charged helium ions. All right, these alpha particles were doubly charged helium ions, and they have mass of 4u as we have done in the previous chapter, and the fast moving alpha particles have considerable amount of energy. All right, these alpha particles also had energy, and it was expected that the alpha particles would be definitely by deflected by the subatomic particles. That means every single ray of alpha particles, that helium particles, will be reflected back. Because why? Because according to the J.J. Thomson, everything inside this atom is positive, and then when helium rays are passed, these atoms will be deflecting. All right, means these rays will be deflecting back very hugely, and only some rays will be going inside these negatively charged electrons, as per expectation was considered. Now, uh, in the gold atoms. Now, since alpha particles were much heavier than protons, all right, alpha particles were doubly charged, so they were much heavier than protons, and proton is already 2000 times more than the electron's weight. And he did not expect to see large deflection. So this was the deflection completely. Alpha particles were passed, and these were the atoms. It was the gold atoms, as we can see. And but the alpha particles scattered experiments and gave totally unexpected result. Means they have after expect scattering, they gave the unexpected result. And what were the observation? Most of the fast moving alpha particles passed straight through the gold foil. Means he thought that only few will be passing, and every other ray of alpha particles will be reflecting back. But a completely opposite happened. Everything was passing and only few of them were reflecting back. So new things were formed. All right, and most of the fast moving alpha particles pass through the gold foil, and some alpha particles have deflected by the soil by small angles, means deviation was little, and one out of every 12,000 particles appear to be rebound. That means if 12,000 particles have been sent, only one out of those 12,000 will be reflected back. In other words, Rutherford, this result was almost an incredible. If you fire a 15-inch shell to a piece of tissue paper and it comes back and hit you. All right. So here is the gentleman Rutherford. All right. He is known as the father of nuclear physics. He has done work on the radioactivity as well. Now, uh, after similar reasoning, Rutherford concluded from the alpha particle scattering experiment that most of the space inside the atom is completely empty. That means the atom space in between is completely empty, and because most of the alpha particles pass through the gold foil without getting deflected. All right, and very few particles were deflected from their path, indicated that the positive charge of atom occupies very little space. All right, and a small fraction of alpha particles were deflected by 180-degree, indicating that all the positive charge and all the positive charge and mass of atoms were concentrated in a very small volume within the atom. Now, what he told, let us understand it once more, that the atoms are completely, most of the atoms are, almost all the atoms are emptied from inside. All right, as all of the rays pass through it. Now, very few particles were deflected, indicating that the positive charge of atom occupies very little space. That means the positive charge of atom is occupying very little space. Hence, uh, very small deflection can be seen, and very small fraction of alpha particles were deflected by 180-degree, indicating that the all positive charge and mass of the atom, that is the mass of the atom, is concentrated at the very small volume inside a place. Now, the radius of nucleus is about 10 to the power 5 times less than the radius of atom. He also concluded we can get through that idea that the nucleus inside an atom is much smaller than the atom. That is 10 to the power 5 times less smaller. That is the radius. And the positively charged center in an atom called the nucleus. That means nucleus is there, which is positively charged center. What he told, and nearly all the masses of an atom resides in the nucleus. This was his observation, and the electron revolves around the nucleus in circular path. All right, and the size of nucleus is very small as compared to the size of atoms. Now, this were the complete observation done by the Rutherford, though it was very important, and it completely outlook change and brought some constructive changes in that atomic theory. All right. Now, what were the drawbacks of Rutherford model? The revolution of electron in a circular orbit is not expected to be stable. If an electron is completely continuously revolving around nucleus, then it would be unstable, because If it computes, if it's keep on moving, it will have some kinetic energy. All right, and that kinetic energy will result in breaking the completely atom. But it was stable. These things are not breaking up. So it was not expected any of that. Any particle in a circular orbit would undergo the acceleration. Means it is in circular path, it will have acceleration, it will have kinetic energy. All right, both centrifugal and centripetal force will be applying on it, and during acceleration, charged particles would radiate energy. All right, radiation of energy will be taking place because it is charged particle and it is keep on accelerating in a circular path. Thus, the revolving electron would lose energy and finally fall into the nucleus. After losing the energy, it will fall into the nucleus, and the atom should be highly unstable because of that. Matter would have been existed in the form that we know that atoms are quite stable, but in actually the atoms are quite stable, but as per the observation of Rutherford, it was expected that the atoms are quite unstable. Now, what is the Bohr atom model of atom? And he was the gentleman. The Neil Bohr postulates about the model of atom. Only certain special orbits known as the discrete orbits of electrons are allowed inside the atom. He told under that. And while the revolving in the discrete orbit, the electron do not radiate energy. While revolving in discrete orbit, the electron do not radiate energy. That means the electron do not radiate energy, does not loses the energy if it's on discrete orbits. This was Neil Bohr. He done that the specific orbits are there, known as the discrete orbit of electrons, are allowed inside the atom. Now the orbit or shell are called the energy levels. That is N, K, L, M, N. All right, K, L, M, N. K is two. Two. It can expect two electrons. L is 8. M is 32. All right. Here it has been given KLMNO, KLMN, and now the neutron. He told about the Neil Bohr gave the model of the shells, energy shells inside the atom. And now the neutron. The J. Chadwick discovered another subatomic particle which has no charge and a mass nearly equal to the proton. Now proton was already heavier, 2000 times more heavier than the electron. And now there is another particle known as neutron which is equal to the size of proton. So eventually, they named it neutron, and the neutron are present in the nucleus of all atoms except hydrogen. Means instead of hydrogen in every atom, the nucleus has been present, and the mass of an atom is therefore given by the sum of masses of proton and neutron. Now, electron doesn't have much higher mass. Whatever mass we had are proton and neutron. So, if we want to find out the atomic mass, so we will add the neutrons and protons of that area, sorry, of that atom. Now electron distributed in different orbits. Now we will discuss about this, and it was suggested by the Bohr and Bury, this guy Neil Bohr and Bury. And he told that the maximum number of electrons present in a shell is given by the formula 2n square. All right, maximum number of electrons given by this, where n is the orbit number. All right. Now the first orbit or K shell, the first orbit is the K shell which is closer to the nucleus. It is 2 into 1 to the power square is equal to 2. Means it can accept only 2 electrons in it. The second orbit is L, which can only accept 8, and the third orbit is 18, while the fourth one is 32. So 2, 8, 18, 32, and the maximum number of electrons that can be accumulated in the outermost orbit is 8. That means in the outermost orbit, the maximum number of electrons can be accommodated in the outermost cell should be 8. It should not be more than 8. All right. And the electrons are not accommodating in a given shell unless the inner shell are filled. That means if inner shell from the nucleus side, if it is not fulfilled, so outer side of elements won't be present. So that if outermost are fulfilled, then the electron which is revolving in the closer nucleus range, it will be radiating energy and it will fall inside the nucleus, and hence it will make the atom unstable. All right. But In order to stop that, he made it up that the nucleus, the shells, the electrons which are revolving around the nucleus will only shade the shells if it is completely fulfilled from the inside to outside. All right. And maximum number of electron that can be accommodated in outermost orbit is 8. Outermost orbit is 8. You have to understand. And electrons will not accommodate given shell unless the inner shell are filled. So it will be having in a stepwise manner. All right. Now the concept of valency is again here. The electron present in outermost shell of an atom are known as valence electron. All right. Whatever the electrons are present in the outermost shell. Now here it is. This is the outermost shell, and in neon these are the outermost shell. When ferrous, here is the outermost cell. Oxygen, here is the outermost cell, and these are the atoms. So this is the valency, the outermost cell. The electron present in the outermost shell of an atom are known as the valence electron, and the outermost shell of an atom can be accommodated a maximum of 8 electron. That means it cannot accommodate more than 8 electron, the outermost shell. What exactly was there? 2, 8, 18, 32, and the outermost electron can only hold or accommodate only 8 electron. And the completely filled with 8 electron in the outermost shell shows the little chemical activity. Their combined capacity of valency is 0. All right. If the outermost shell has 8 electron, that means there will be very low and little chemical activity will be taking place, hence the combining capacity of the valency is 0. Now the helium atoms have 2 electron in its outermost shell, and all other elements have atom with 8 electrons in the outermost shell. All right. That means helium atoms has 2 electron in its outermost shell, and other elements have atoms with 8 electron in the outermost shell. Combining capacity. Now their tendency to react and form molecule with atoms of the same different elements was thus explained as the attempt to attain fulfilled outermost shell. Means if it has completely outermost shell, so it won't be combining with the other elements. Hence, that atom will be completely stable on its own. But if there is less number or more number of electrons present in the outermost shell, at that time the atom will require some other elements. It may be of the same element or some other elements to get combined, and this is how it will make itself stable by giving and taking electrons in the from the outermost shell to get stability. And the atoms would thus reach to achieve an octane in the outermost shell, and done by sharing, gaining, or losing electron. Either they will share, and in share they will either gain or lose the electron. Now the hydrogen, lithium, sodium atoms contain one electron each in their outermost shell. So if they have a less number of electron, so they will give the electron to the other elements or other atoms. And if more number of atoms are there, all right, if more number of atoms are there, so it will take it to fulfill until 8 electrons. So they said to have valency of one, as the hydrogen, lithium, sodium, these all are having one electron in their outermost shell. So if they are having one electron in the outermost shell, that means they have valency of 1. Now, valency of magnesium, aluminium, it has 2 and 3 respectively electrons in there. So they will have 2 and 3 respective valencies in the, all right. And the electrons in the outermost shell of an atom is close to its full capacity, then the valency is defined in the different way. The fluorine atom has 7 electrons. Now it has 7 electrons, so in order to get fulfilled, it will take 1 electron from some other atoms. All right, to get, and so its valency could be 7. All right, 7 electrons in the outermost shell, and its valency could be 7. But it is easier for fluorine to gain 1 electron instead of losing 7 electrons. Hence, its valency is determined by the subtraction 7 electrons from the octane. This gives a valency of 1 for fluorine. Now, people will say that now 7 electrons are present in the outermost shell, hence its valency is also 7. But it is not true. The valency is actually the gaining or taking of electrons. If you have one or two or two, three electrons in your outermost shell, at that time you have the valency of 1, 2, 2, 3. All right, but if you have 7 number of electrons in your outermost shell, then it is easier that fluorine will gain one electron to in order to get fulfilled. So at that time also it will have a valency of 1. Alright, it has valency is determined by subtracting 7 electrons from the octet. That means you subtract from the octet, that is 8 minus 7, you get 1. So it has a valency of 1. Now if we talk about the oxygen, the same, and the atom of each element has definite combining capacity known as its valency. So the this is what the valency is all about, how much it can combine with other atoms. Now let's talk about atomic number and mass number. What is atomic number and what is mass number? The protons are given in a nucleus of an atom. All right, protons are present in the nucleus of the atom, and the number of protons of an atom which determines its atomic number. So number of protons decide the atomic number. Now it is denoted by Z. The elements are defined by the number of protons they possess. All right, elements are defined by the number of protons they possess. Hence, hydrogen Z is equal to 1. In hydrogen atom, only one proton is present in the nucleus. Similarly, in carbon, Z is equal to 6. Means number of protons is equal to number of atomic number. Number of protons is equal to atomic number. And when it comes to mass number, then we will combine protons and neutrons together. All right. Now, mass number, the mass of an atom is practically due to the proton and neutron alone. So we will combine both of them to get the mass number. So for carbon, earlier it was atomic number was 6. So the mass number is around 12. Now we have understood about it. Now this is the main thing which you have to remember. Now the symbol of element, the symbol of element, can we can take carbon. So in the space, in the space of x, C will be written. Our mass number will be on the top and the atomic number will be on the downside. So if we take C, then in the space of Z we can take 6, and in the place of A we can take 12. And if we take nitrogen, it is written as like this, N714. All right. And what is isotopes? In nature, a number of atoms of some elements have been identified, which have the same atomic number but different masses of number. All right, means they have isotopes. Iso means same. Topes, that is find out some way to make you remember. Now, atoms, the same atomic number but different masses. Isotopes means top. What is top? Top is the mass. Iso means different. Means on top, whatever at the top is mass. So they will have different masses but same atomic number. Simple. Alright. Isotope. Top is mass. So they have different masses but same atomic number. For example, the same hydrogen isotopes, the three atomic species are the protonium, protium, deuterium, and tritium. So here you can see the lower side is same, 111. Everywhere you can find one is there. All right, but in the on the top we have 3, 1, and 2. Means top is different and bottom is same. So isotop. Iso means different top, different top. Now, atomic number of each is 1, but the mass number is 1, 2, 3, respectively. Hence, if we talk about the carbon as well, carbon we have 2, that is the bottom is 6 only, but the top is different. Again, C is the isotope, and chlorine is another example, 17, bottom is same, but the upper side is different. On the basis of these examples, isotopes are definitely as the atoms of same elements having the same atomic number but different masses. All right, they have different masses but same atomic number. Now, isotopes of hydrogen we have talked about is protium, deuterium, and tritium. How it is protium? Protium is 1, so 1 1. Deuterium is 2. Dew means 2. Hence, it will have mass number of 2. And tri means 3. That means mass number will be 3. Now, each isotope of an element is a pure substance, and the chemical property of isotopes are different from their physical properties. Are different. All right. The chemical properties of isotopes are different, are similar, but the physical property is different. Now, the chlorine occur in two isotopes as we have discussed about it, and the average atomic mass of chlorine, if you want to find out, we can get it 35.5. All right. And if an element has no isotopes, means it doesn't have two different mass numbers, then the mass of its atom would be same as the sum of proton and neutron. Means if there is no different masses, at that time we can consider that the mass of proton is equal to mass of the electron. All right. Or the atomic mass is same as the sum of protons and sum of neutrons, means both are equal. Now, chlorine, we have talked about it. It is similar. Now, yes. Now, what is the application of isotopes? Means what happens if something has different masses? Now, an isotope of uranium is used as fuel in the nuclear reactor. All right. Means if uranium, different types of different mass are present. All right, and this is used as a nuclear reactor fuel. And an isotope of cobalt is used in treatment of cancer. All right, and an isotope of iodine is used in the treatment of goiter. Now let's talk about isobar. Now we have talked about isotopes, means top was different. Isobar, bar means bottom, means iso means different, different bottoms. All right, let us consider two elements: calcium and calcium atomic number of 20, argon atomic number of 18. Means their atomic number, that is their bottoms, are different, and the number of proton in these atoms is different, but the mass number of both of these elements is 40. That means the calcium and argon has the mass number of 40. That is the total number of nucleons. What is the nucleons? Nucleons means protons plus neutrons is nucleons, is the same as the atoms. Atom of different elements with different atomic number which have same mass, means both of the atoms are different, and still they have, both of the atoms are different, they have different mass numbers, but sorry, they have different atomic numbers, but their mass numbers are same. Hence, this time these are known as isobars. Now we have understood it well. An isotope means, iso means different, top means top is different. What is in the top? Isobar is there. Sorry, not isobar. Atomic mass is there. And in isobar, iso means different, bar is bottom. Now atomic number is different, but atomic mass is same. So here we learned many things. Discovery of electron and proton goes to J.J. Thomson and C. Goldstein, respectively. The Thomson found out about the electron, Goldstein found out about the proton. Now, Thomson proposed the electrons are embedded in the positive sphere, like a watermelon, but it was wrong. Rutherford alpha particles, helium doubly charged alpha particles, it give us the formation of empty space between the nuclear. It told us about the presence of atomic nucleus and the free space in between those, in between the nuclear atom. Sorry. The Rutherford also proposed that the tiny nucleus particles inside the atom and the electron revolves around it, and the stability of atom could not be explained by this model. Then Niels Bohr came and he gave different types of shells. All right, energy shells, KLMN, with accommodation of 2, 8, 18, 32, as well as he also told that the last shell cannot hold more than 8 electron. All right. In order to get stability, it can either gain or lose some electrons. Chadwick discovered about the nucleon neutron. Sorry, Chadwick discussed about the neutron, and then the three subatomic particles were discovered: electron, proton, and neutron, where the proton is 2000 times heavier than the electron, and proton and neutron are quite similar in size. Now electrons are negatively charged, protons are positively charged, and neutrons are neutral. All right. I hope it is understandable now. And shells of an atom, KLMNO, KMLMN. All right. Now valency is combined capacity of an atom. The more it can combine, the better valency it has. The atomic number of an element is the same as the number of protons. All right, the atomic number is same as the number of protons. So if you want to find out the number of protons, just find the number of atomic, just found its number. The atomic number is known as equal to the size, the number of protons, and the mass number is equal to the combination of protons and neutrons. All right. And what are isotopes and isobar? Iso means different, top is atomic mass, and bar is in the bottom. Bottom is bottom is atomic number. Means isotope means elements having same atomic number but different masses. Atomic masses are known as isotope. Isobar, elements with different atomic number but similar or same atomic masses are known as isobar. All right, and elements are determined by the number of protons they possess. And elements are determined by the number of protons they possess, because protons will decide the atomic number, and atomic number cannot be different of the same element. All right. So hence we have discussed the fourth chapter as well, and I will teach 10th class NCRT with the same to get the proper flow, and then we will go to the biology and then the physics to in order to have a better mindset of those things. All right. So next time I will be continuing about the chemistries, 10th class chemistries, so that we can have a better understanding over these things. All right. So thank you everyone for listening, and I don't know what to say. If you want to subscribe the channel, it will be really helpful if you're preparing for any examinations, or even if you're college students or board students. I'm sorry. So it will be helpful. So thank you everyone for listening, and I will continue my journey. I will do some book reviews as well, as I read a lot of books, not just studies but outside of studies also. And I will do the book reviews. I will do some daily newspaper reading as well for you guys. And though I'm not continuing currently because I'm already busy with my job, and I will also do some syllabus analysis of some competitive examination, different kind of competitive examination. You guys can message me and comment on my YouTube channel. And so if you are known about my Instagram ID, you can also message me. I will make the videos on that. I will be also discussing about the SSB interviews which are taking place. I've given two so far, and that's all. We will practice some maths as well, but maths is not possible here because I'm using laptop. So but we will do some analysis. All right. Based on those analysis, things can be done. All right. We will discuss science, history, geography, economics, polity. Everything will be discovered, and everything will be discussed, and from the NCRT perspective. And after doing the complete syllabus, we will go through the previous year questions which have been asked, and we will also analyze everything. So thank you everyone for listening, and Jai Hind.